Hello, welcome back to the Looc. In this segment we are going to take a look at exceptions and exception handling. We will discuss what exceptions are and how they are handled, when to use exception handling, the use of try blocks, how to throw an exception to indicate a problem, how to use catch blocks to specify exception handlers, the use of the finally block to release resources, and properties of exceptions in general. Conceptually, an exception is an indication that a problem occurred during a program's execution. Exception handling enables us to write applications that are prepared for such problems, and they can deal with them and continue execution. In other words, it allows us to write robust and fault-tolerant programs. The first case we are looking at is a division by zero example. A division by zero example when we try to divide a number by another one, and the number, due to erroneous input that we divide by, is 0, and that obviously is a problem. So here is the code with no exception handling. So we need a numerator and a denominator. We enter two numbers with a console read line and convert it to integer by convert the 2 in 32. So there's a numerator and a denominator, and then we divide the 2. That will be our result. It's an integer result, so it will be rounded down to the nearest integer if we enter integers. And we display the result, all three numbers, the numerator, the denominator, and the actual quotient, the result. And here are examples of running the program. If we enter 100 and as numerator and 7 as denominator, then the result will be 100 divided by 7, which is 14. There's a fractional part, but this is integer division. And the second input shows the case when an error occurs. So the numerator is again 100, but the second integer we enter, the denominator, is 0. This is a mistaken entry, but users can enter incorrect data, as well as we could have read this data from a file and it could have been incorrect there. But if the program now proceeds and tries to carry out the division by 0, then the result is what we see on the slide, that we get a message that an attempt was made to divide by 0 and that this is an unhandled exception. So again, the problem is that we did nothing about it. So our program was not prepared and not ready to handle this kind of situations. Another problem can occur when we enter input entries that are not the right format, so they are not really numbers. We enter 100 for the numerator and something else, like in this case the word hello, for a denominator. And that's again ends up with the program crashing, and we get a runtime error that input string was not in the correct format, and it's indicate where actually this problem occurred, and we are going to talk about this kind of printouts later. So let's try out this situation, and then we'll discuss what to do about it to make this program better so that it doesn't crash when an error occurs. It's important to keep in mind that in the first version we don't make any attempt at exception handling, and as a result our program has a runtime error, a crash. And runtime errors are the errors we want to avoid above all. Compile time errors we can correct by modifying the code, but runtime errors are a big problem. So here is our class with an entry for main function. So we get the numerator first, console. It's a write and we input we enter the prompt, say please enter an integer numerator colon space, and following that we create the variable for it, so numerator equals, and we have to do a convert and to int 32, and then we read in the actual value, so it's a console read line, and that's our input. Then we get the denominator, which is the same two lines in essence with minimal modifications, so I'm going to copy that. So you just have to modify a denominator, and likewise here. And finally we have to do the division, so divide the two integers, then display the result. So here is our result, which is the two numbers divided, and we attempt to display the result, which actually works correctly as long as we put in the right input, but the problem occurs when we don't. So result, and as integers we have three input parameters divided by the next one, also an integer, and that equals the final one, also an integer, and numerator, denominator, and result. There. So that's our program, real brief, and we try to divide two numbers without making any attempt whatsoever to check or validate the input. So let's compile it and run it with Ctrl F5. So here is our input the first time. Maybe I pull it over here so that it's better visible together with the code. I can actually make that line two lines if we want. So enter an integer numerator, so suppose we enter 100, a denominator, suppose we enter 7, and the result is correct. So everything goes well as long as the inputs are correct. Now let's make a mistake. This time intentionally, generally not intentionally. So Control F5, and the numerator is 100, and the denominator, here we make a maybe unintentional error, divide by 0, and then our program crashes and we get an error message that a user typically wouldn't necessarily understand, and would be without help to do anything about it. Let's try the wrong format case. So here is the input 100, hello for denominators, so-called, and there goes another runtime crash, and again we have a problem. So this kind of vulnerabilities are the problems that exception handling was designed to solve. So we need to modify the program. Note that what we see in the command prompt window, the stack trace, which displays the exception name and the path that led to the exception, there are @lines that indicate the methods or functions that were called and that in succession failed. The first @line is the throw point, the initial point at which the exception occurred. And then if there were methods calling this method, then those also are indicated. So there are two kind of exceptions here. One is the division by 0 exception, and the other is a format exception. A format exception is when, for example, a convert method cannot execute because the string that it represents is not a valid integer. So next, let's look at a modification of this program in such a way that it does not crash when an exception occurs, in which we are going to catch an exception, and we are going to handle it in one way or another. For example, if there is a division by 0 error or a format problem, we can ask the user that, we can inform the user that these are incorrect values and ask the user to enter another set of values. So instead of crashing, the program responds to the problem, sends a message to the user of what the problem is, and offers a chance to correct it without crashing. That's what exceptions are about. So let's look at the modified form of the program. This time we are going to put most of the program into a do-while loop, controlled by a Boolean variable continue loop that is set to true, and this loop will basically is a sort of infinite loop that keeps asking for new values from the user as long as it receives correct values. Within the do-while loop, we are going to create a try block, and that's where the entire earlier program code will be placed. So within the try block, we are asking for the two inputs, and try to compute and display the result. And the advantage of the try loop is that it can be followed by the try block, that it can be followed by catch blocks, in which for every exception that can occur, we can provide exception handling. So in our case, we saw in the first attempt that two kind of exceptions can occur. One is called a format exception, when the input by the user was not in the right format, it wasn't a valid integer as a string, and the division by zero exception, in which case we attempted to divide the number by zero. So we catch both of this. That means we write a catch block for each type of error, and the names format exception and divide by zero exception are defined by the .NET framework, and we give some name in just format exception and divide by zero exception, two variables that are of that type, and as handling we write out the message of the format exception. Note that it has a message part, that's the one that says division by zero or something, so we don't even have to write the information that informs the user of what the problem was, and then we write a message of what to do about it. You must enter two integers, please try again if it was a format exception, or that in the second case 0 is an invalid denominator, please try again. So we give the user a chance to do it, and that's the end of the while loop. And note that in the try block, if no exception happens, so we got to the last line of the while loop after displaying the result, if no exception happens, then we reach the line line 30, continue loop equals false, which simply exits out from this loop, and we are done. So the catch blocks happen only when there is a problem, there is an exception. Otherwise the program continues as normal, and if an error occurs and the user enters new numbers and this time they are correct, then we do the division, display the results, and the continue loop variable is set to false, which means that we exit the while loop. So here is the output. Enter an integer numerator 100, 7 divide by 7, we get the result, and no difference. So in this case we don't see any reference to the catch block and the try block, because they didn't come into play at all, because there was no error. However, when we enter 0 as a denominator, then the message appears, attempted to divide by 0, provided by .NET, and then our message, 0 is an invalid denominator, please try again. And then the user can try again and say, yes, I wanted to enter 7, not 0. And then this time the program runs correctly. And note that there were two inputs. The first is incorrect. The program suggested correction, and then ran again, and eventually we got the right result, and there was no crash. And that's the advantage of exception handling. Here is the other possible problem: 100 divided by the string hello, and that again is produces a message. Input string was not in a correct format. From .NET, and we wrote the message, you must enter two integers, please try again. The user realizes, oh yeah, hello is not exactly a denominator, so this time I enter 107, and the program again correctly runs to its conclusion without ever crashing once. So let's try to modify our program accordingly. So in the main function, we have to define a boolean called continue loop, and we set it initially to true, meaning that as long as this is true, continue looping. So it's true initially, and we exit from the loop only when it turns false. So here is the body of the loop, the do part, and then the try and catch blocks follow, and then in the end, at the end of it comes the while part, and while continue loop so equals true, and that will be the end of our do while loop. So that's our loop, and within it we are going to have a try and two catch blocks. So we attempt to retrieve user input and calculate quotient, and this time there will be a try block for this, like that, and that's the end try. And in essence we are going to place our actual code that from the previous attempt right in the try block. So we say that we are only making a try because problems can occur in this segment of the code, and therefore we want to prepare for that. The only thing we need to remember that if we successfully completed this part, then we have to change the continue loop variable to false so that we can exit the loop, and that will be the try block. And still within the while loop we have to now provide catch blocks for each of the two possible exceptions that can happen. So this is end of the first catch, and another one, and this is for the second catch. So that's our structure, and that's what we are going to handle. It's not done, so we have to get rid of error messages. So format exception, that's the one we use, and we just call it format exception as a variable, and we are going to handle it here. So console write line, and this time we are just going to drop a new line and then follow by format exception, our own variable format exception dot, and it has a message, a property that simply a short sentence of what the problem was, so that the user knows, and then we add our own message that something like you must enter two integers. Please try again, and a new line. So that's catching the first exception, and the second is the division by zero exception. So we call it div by zero exception, and that's what we are going to use. So in this sketch block again, console.writeLine, and well, this is actually the same as the previous one, but you can retype it. So new line followed by div by zero exception dot message, and when that's done, that we can add our own custom message to the effect that writeLine, and we know that in this case division 0 was, so 0, the problem, so 0 is not a valid denominator. Please try again, and a new line. So that's that is our modified program. So let's look at the code here, that within the main method, and that's the end of while, the while loop, and with that we are done. So that's the end of the main method, and with that the end of the class. So if we look at the code, we see the issue that we placed our entire code from the previous try, which did not handle errors, within a try block. And in general, in programming any code segment that can possibly throw exceptions, in other words, that possibly can cause problems if something is wrong, we typically place them within a try block, and following by one or more catch blocks that catch the various errors that can happen, and handle them. In other words, they do something about it. At the minimum, they inform the user and typically offer another try. So let's save our program like this, and recompile and run, and it will work better this time. So here is our input window. So enter an integer numerator, say just as before, we enter 107, and in this case we have no problem, so we get the right result. However, if I run it again, Control F5, or so I think, so this time enter 100 as numerator, and then a problem occurs. I enter 0 as the denominator. Instead of crashing and sending, you know, a trace, a stack trace, it informs me, the user, what the problem was, attempted to divide by 0, and then our custom message 0 is not a valid denominator, please try again, and then in the loop we are back And here is our second chance, and this time I realized, I really wanted to enter 7, not 0. And we computed 100 divided by 7 as intended, despite the fact that on the first try I entered an incorrect value. But the program didn't crash. It continued without missing a beat and gave me a chance to do better, and eventually ended with the correct result. In other words, this was a much more robust program than the first. And as a matter of fact, it's so robust that it can handle even the other exception that can happen in this case. So I entered 100, and then, distracted by something, I entered something incorrect for the denominator. It entered, and then, the first case it just crashed. Now we get an information that input string was not in a correct format, and our custom message that you must enter 2 integers, please try again. So here is my second chance, 107. So we are back like in the first case, like as if nothing happened, and on second try we correctly compute the result as intended, without crashing the program, and it successfully completes even though erroneous inputs happened. But we prepared for it by catch blocks, placed the potentially dangerous code in a try block, and that took care of the issue of not crashing. In the next segment we take a look at more details at exceptions and related concepts.